Hello children, in this video we are going to discuss about basic concept of a differential equation. We will study how to define a differential equation and how to find the order and the degree of a differential equation. So let us start. Differential equation. An equation containing an independent variable which is normally x, dependent variable which is normally y, and differential coefficients of dependent variable with respect to independent variable, that is dy upon dx, d2y upon dx square, d3y upon dx3 and so on, is called a differential equation. So these are the examples. Y is dependent variable, x is independent variable, and dy upon dx or d2y upon dx square or d3y upon dx3 are differential coefficients of dependent variable with respect to independent variable. That x is independent variable, y is dependent variable, and dy upon dx, d2y upon dx square and d3y upon dx3 are differential coefficients of y with respect to x. Now, order of a differential equation. The order of a differential equation is the order of highest order derivative appearing in the equation. Highest order derivative means, suppose in the equation we find dy upon dx or y dash or y1. It means it is a first order. If we find d2y upon dx square or y double dash or y2, it means second order. If there is d3y upon dx3 or y triple dash or y3 in the equation, it means it is of third order. And if dny upon dxn or y dash 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 n times or by n involved in the equation, then we can say the equation is of nth order. Examples: dy upon dx plus y equal to sin 3x. In this equation, only dy upon dx, that is first order, is involved. So its order is 1. Here d2y upon dx square and dy upon dx both are involved, and which is the highest order? Second order, that is d2y upon dx square. So highest order is the second order. So order of this equation is 2. Here by triple dash means d3y upon dx 3, that is third order derivative, second order derivative, first order derivative. So which is the highest order? Third order. So order is 3. Order of this equation is 3. Now, degree of a differential equation. The degree of a differential equation is the power of highest derivative present in the differential equation. Power of highest order. Now, there are few steps to find the degree of a differential equation. Number 1, the differential equation must be a polynomial in derivative, that is dy upon dx, d2y upon dx square and so on. The equation must be a polynomial in the equation. Polynomial form is like this. You have already studied in class 9th. a1x plus a2x square, a3x cube and so on, an xn, where a1, a2, a3 means coefficients are real numbers, and the power of x must be a non-negative integer. But in the case of differential equation, it is n is a positive integers only. Then exponent or power of highest order derivative will be the degree of differential equation. Means these are the few steps. Number one, equation must be a polynomial equation. Then second step, we will find the highest order derivative, and then third, we will find the power of this highest order derivative, and this power will be the degree of differential equation. For example, here by triple dash whole square plus x square by dash cube minus 2x plus 11 equal to 0. So clearly this is a polynomial equation. First step is completed. Highest order is by triple dash, that is d3y upon dx3 is the highest order. What is the power of this highest order? 2. So degree of this equation is 2. Degree is equal to 2. In this case, again you can see this is fourth order derivative, this is second order, this is first order. So which is the highest order derivative? This, that is fourth order, d4y upon dx4. So highest order is this, and what is the power of highest order? 2. So again degree of this equation is 2, and here you can see d3y upon dx3, d2y upon dx square whole square plus 5 dy upon dx plus 21 equal to 0. Now what is the highest order here? d3y upon dx3, and what is the power of this highest order? 1. So degree is 1. To find the degree of a differential equation, in this step, it is given that the differential equation must be a polynomial equation. Suppose if the differential equation is not a polynomial equation, then can we find the degree of a differential equation? So I have taken these 4 examples. You can see clearly d2y upon dx square plus sine d3y upon dx3. This is not in a polynomial form. Here d4y upon dx4 cos d3y upon dx3 equal to 0. This is not in a polynomial form. And similarly, this is equal to x square log d2y upon dx square or the square root, etc. All these 4 examples are not in the polynomial form. So what will be the degree? The degree will be not defined. And what is the reason? The reason is that the differential equation is not in polynomial form. Now let us take few examples to find order and degree of the differential equations. Highest order is d2y upon dx square. So order is 2. And power of this highest order is 1. So degree is 1. Second question. d2y upon dx square is the highest order derivative. So order is 2. And its power is also 1. So degree is 1. Now here the highest order is d2y upon dx square. So order is 2. But it is not in the form of polynomial. So degree not defined. Similarly, highest order is d4y upon dx4. So order is 4, but it is not in the polynomial form. So degree is not defined. Here d2s upon dt square is the highest order, so order is 2 and its power of highest order is 1, so degree is 1. Now, however, we have seen sin y here, but this equation is in the form of polynomial in d2y upon dx square and dy upon dx. So, its order is 2 and degree is